PHA, an interconnected solution. I'm fairly certain everyone loves food, right? But what if I tell you every year in New Zealand, 200,000 tonnes of food waste end up in landfill? But the problem doesn't just end there. When all this food waste gets buried, it decomposes without oxygen, generating methane, a very harmful greenhouse gas which contributes to climate change. Now, as Kiwis, I'm also fairly certain we all love our ocean, right? But what if I tell you every year in New Zealand, 252,000 tonnes of plastic end up in landfill? But the problem doesn't just end there. All of this plastic causes serious problems like this, and this. Both these problems contribute to climate change, which should be a problem that everyone is familiar with. Māori believe that there is a deep kinship between the tangata whenua and environment, which means we all have the responsibility to be kaitiaki, guardians of the earth. So how can we fulfill our roles as kaitiaki when two serious problems like this exist? With a growing reliance on plastic in society, the ideal solution will actually provide a feasible alternative to plastic and also reduce our food waste. Te Awa Māori, the Māori worldview, believes that everything in the world is interconnected. So, following this philosophy, what if we can solve two problems with just one solution? We can. PHA is a solution that can solve both issues as it provides an alternative to plastic and uses up our excess food waste. PHA is a carbon-based polymer which can be used to create biodegradable plastic. It has similar properties to regular plastic, but without the negative environmental consequences. It can be produced biologically by bacteria, as long as there is a carbon-rich source provided which the bacteria can feed on. PHA has been around for ages, having been synthesized through monocrops like corn or sugar, which are both carbon-rich. However, this is unsustainable as such crops require arable land which is not only expensive to maintain, but can lead to a loss of wildlife habitat. The large cost of production associated with PHA is the main reason why it has not been developed into the market, despite its environmentally friendly properties. However, food waste can provide a low-cost, carbon-rich source for PHA production. Food waste is rich in sugar, starch, and protein, allowing for PHA to be produced from food waste in 5 main steps. Firstly, food waste would have to be collected from places like food industries and households, then pre-treated. For example, composite food waste would have to be processed into smaller components. Then, food waste can be broken down into PHA precursors. PHA precursors provide the carbon-rich conditions and compounds for bacteria. The best method to break down food waste is using enzymatic hydrolyzation. Enzymatic hydrolyzation uses water and enzymes to break food waste down into smaller, simpler molecules, such as sugar or fatty acids. These molecules can then be used to create a carbon-rich PHA precursor. While this is proceeding, bacteria would have to be cultivated under specific conditions into a population capable of producing PHA. The most common bacteria that can be used is C. necator. Bacteria will then be harvested and fed with PHA precursors, which produce PHA as a storage product through a biosynthesis pathway from simpler molecules. Lastly, PHA is extracted from the bacteria and can be used to generate biodegradable plastic. There are so many benefits to New Zealand through this process. New Zealand obviously benefits environmentally, as there's going to be less plastic pollution. This process has no hazardous byproducts or consequences as plastic becomes biodegradable. What this means is that PHA can disappear in the environment within 2 to 12 months. There's also less food waste, which releases less greenhouse gases, which contributes to a better climate. New Zealand also benefits economically. We have less food waste as it's being recycled, saving up to $1.17 billion a year. Also, in today's society, the increased awareness for climate change means there is an increasing consumer demand for better alternatives to plastic packaging. PHA can serve as a good alternative, increasing the likelihood for widespread commercialization, which not only further benefits the environment, but creates more jobs. This process also fulfills many acts which New Zealand is obliged to follow, such as the Zero Carbon Act, benefiting the environment. So, overall, although initially this procedure may be difficult and expensive to implement, over time with more investment, the interconnected solution will greatly benefit New Zealand as it uses food waste to create biodegradable plastic, which reduces plastic pollution, helping to tackle climate change, which we should all be responsible for as kaitiaki. Ultimately, PHA provides Aotearoa with the capability to solve two major problems with one interconnected solution. Thank you.